This conference will now be recorded.
So as we discuss in database architecture, Oracle server consists of Oracle instance and Oracle database. An Oracle instance is a memory. An Oracle instance we had SGA and we had background process. So all these components we had done. Now what is database? So basically database is a set of files, okay, that stores the data and which reside on the disk, and these files can exist independently of a database instance. Okay, so you can see in the diagram we had data file, we had control file, we had a redo log file. So these files are important for your database. So data file is basically a physical file which was created by Oracle database, and it contains data structures like tables, indexes, views, etc. Okay, and database writes data to these files periodically on the basis of the rule which Oracle follow. Okay, and we will discuss more about data files in data file chapters. So we had a system data file and we had a non-system data file. So if you see my this diagram, so here you can see that we have these types of files. So which one is required for a startup, and which one is for optional, which one is for mandatory. So you can see that control file is mandatory, parameter file is mandatory, online log file is mandatory, ADR is mandatory, and backup files, archive log files, flashback logs, blockchain tracking, wallet, all are optional, and password file is also mandatory. Okay, so these are the files which belongs to called as database system files, right? And we had user data file also. From 10G onwards we had two system files, one is system and one is sysox. Okay, and before 10G it was only system. Okay, and after that when we create a database through DBCA, so how many files created? Can anyone tell me? We did this. I'm asking, when you create a database through DBCA, so how many files will be created? Okay, and the next important file is control file, which is a root file actually that tracks the physical components of the database. And online log file is a file which contains record of changes which made to data. So we will discuss more in details later on when we discuss data file in separate chapter, when we discuss control file in separate chapter, when we discuss online log file on separate chapter. Okay, so the usage of data file basically it has table space in that one or more data files, okay, which confirm operating system on which database is running, and the data for database is collectively stored in the data files located in each table space, and database base must have system and sysops, and Oracle database automatically allocates the first data files of any database for the system table space during data creation, because system table space contains the data dictionary, which is a set of tables that contains database metadata. And database also has an undo table space and a temporary table space. Okay, so so can we you tell me one table can reside into two table spaces? Okay, so the table space is basically a logical object, okay, which creates the area in the database, and in that the permanent file is the data file. Okay, so we will see later on this. So first we will discuss about the control files. So as I said, control file is a file which stores metadata about the data file and a non-redo log file like the database name and status, and this information is required by the database instance to open the database. And control file also contain metadata that must be accessible when the database is not open. So it is highly recommended that you make several copy of the control file in your database. Okay, so how many control file we can create, and what is the minimum control file requirement? Tell me minimum and maximum. I think I have asked you guys earlier. Still you are giving wrong answer. Minimum we required one, but recommended we should go with two control file, and maximum we should can create eight control file. Guys, please revise your sessions. Okay, then parameter file, as we know that this the parameter which contains actually parameter and its value, and these parameter is required to configure the instance and to start the instance and to open the database. So parameter file is a text file which is called as p file, and parameter can be a sp file which is a binary file which is called as server parameter file. So can anyone tell me how many parameter we require to create the database for fresh? How many parameters we can use, minimum parameters to create the database? Have you done manual database creation? Who had done manual database creation in this group? If I get a time, so I will show the manual database creation also, so that you can understand how manually we create the database. You are asking everything from me, but you guys are not giving answer my questions. See, one parameter I can use, and I can create that also. That is DB underscore name. Only one parameter I can put in the database parameter file, and I can create it actually. I have checked this practically when I was working on 11G. Okay. Yes, Lakshmi, you are correct. So this is okay. Then we had a password. Sorry. Then we had uh, backup file. So mandatory file is only control file, parameter file, and online envelope file. Password file is not mandatory. I'm sorry, I said mandatory actually. So then online redo log file is also discussed when we were discussing redo log buffer. So first redo entries or changes happen in your database. It will store in the redo log buffer, and from redo log buffer, log writer writes those redo entries to the online redo log file. Okay, so these files are very important because it requires for recovery purpose. excuse me. Then ADR, Automatic Diagnostic Repository, which introduced in 11G. So it holds so many things like if you see my next diagram in ADR, it holds background trace file, it holds foreground trace file, it holds dump, incident package, health monitor report, alert log file. So this ADR is very important, and this is the tool actually ADRCI you can enable, and from there you can manage these types of report actually. Okay, so DBA should better understanding of this ADR is very important to manage the database. Okay, and then go back. We had archive redo log files. So archive redo log files, as we know that when we put our database in archive log mode, then this archive redo log file is come into the picture, and it will stores the redo entries from the redo log file to the archive redo log file. And which process will do this activity? As we discussed in last session, tell me the process name. Yes, perfect. ARCN process. And how many minimum we had ARCN, and maximum how many we had? We discussed this also. Only Ajit answer. Other guys are not answering. Why so? Minimum 4, maximum 30. Guys, you are not revising. Then backup files, this is optional file. It is used for recovery purpose when DBA take the backup. So backup can be system file, sysops file, user data file, SP file, SP file, control file. So all these files are very important. So DBA should take the backup of these files so that if any file is losing, you can recover that. Got it? And that password file is an optional file, and this file enable users using the roles we had sysdba, sysoper, sysbackup, sysdg, syskm, sysrack, and csm role to connect remotely to the database and perform administration tasks. Okay, so password file is used for that. And then we had a blockchain tracking file. So this blockchain tracking file introduced in 10G. So this file helps in incremental backup whenever Arman take the incremental backup, and this blockchain tracking file is there. So actually it will stores the addresses of those blocks which change actually from the last backup. Okay, so whenever Arman is taking a backup, and if you want to speed up your database of backup, so you can enable blockchain tracking file. And when you do Arman incremental backup, so channel processes will read the blockchain tracking file, get the address of those blocks which has new value, and it will directly hit those block and copy into incremental backup set. Got it? So that's why it's very important to enable blockchain tracking file. And flashback logs, when you enable flashback database, then it comes into the picture, and it will create flashback logs, and it is stored in the fast recovery area. And you can use flashback database if flashback logs are available. Okay, so you have to create flashback logs in your database. And then we had a wallet. So wallet is basically a security feature which provides a secure software container that is used to store authentication and signing credential. Possibly, wallet include an Oracle wallet for user credentials, encryption wallet for transparent data encryption, and Oracle public cloud wallet for database backup cloud model. A wallet is basically optional but recommended. Okay, So these are the files. Now, how many files we can multiplex in our database? Tell me the name. How many files we can multiplex in our database? Control file and redo log files. Okay. We could see three files: control file, redo log file, and archive log file. Okay. Two guys answer. What else? Yes, control file, online redo log file, and archive log file can be multiplexed. So it means we can create two or more identical copies and should be posted or created or stored on separate location. Then you will get the benefit. Okay. And which files are required for database startup? Parameter and control file. Okay. Control file, SP file, CT file. Okay, guys, become a smart DBA. In my diagram, it is mentioned required files for a startup: control files, parameter file, online need to log file. It is displaying. Okay, clear, guys. Now ADR. So ADR is basically a background trace file. Is Each database background process can write to an associate trace file. When a process detects an internal error, the process dumps information about the error to its trace file. Some of the information written to trace file is intended for the database administrator, whereas other information is for Oracle support services. So typically, database background process trace file names contains the SID, the background process name, and the operating system process number. So suppose if a RICO process writes its error into trace file, so it's named like this: my test. My test is the database name, underscore RACO underscore 10355.trc. So like this, it will create the background trace file actually. And foreground trace file means server process trace file. So each server process can write to an associated trace file. So whenever server process deducts an internal error, it will dump information about the error to its trace file. And server process also containing SID, but it's contain Aura, actually, and an operating system process number. So server process name like this: my test underscore Aura underscore 10304.trc. So like this, this naming will come. And dump file, basically a diagnostic dump file. You will dump that file by the command. Okay, so dump file is typically a one-time output of diagnostic data in the response to an event, whereas a trace file tends to be continuous output of diagnostic data. Okay, then health monitor report is basically uh, provide the health report of your database. So health checks detect file corruption, physical and logical block corruptions, undo and redo corruptions, data dictionary corruptions, and many more things. Okay, so this health check generate reports of their findings, and in many cases recommendations for resolving problems. Okay, and then incident package. So for the customized approach to uploading diagnostic data to Oracle support, you first collect the data into an intermediate logical structure called as incident package, or you can say package. So package is a collection of metadata that is stored in the ADR and points to diagnostic data files and other files both in outside of the area. So when you create a package, you select one or more problems to add to the package, and the support workbench then automatically adds to the package the problem information, incident information, and diagnostic data like trace file and dump file associated with the selected problems. Okay, and then incident dumps, basically when an incident occur, the database writes one or more dumps to the incident directory created for the incident. So incident dumps also contains the incident number in the file name. Okay, and then the most important helper of the database is alert log file. So alert log file is basically stores the messages and errors whenever you are doing any changes in your database, whenever you are getting any error in your database, and when you start your database. So all the phases steps it will store in the alert log file, and this is the text file and which grows according to the database transactions or activity, and it will not override, basically it will append. Suppose you delete the alert log file, so it will create automatically, or DBA have to create alert log file? Question. Okay, it created automatically, and yes. Now, backup files is more into this actually architecture. So I have taken this diagram. So as you can see, we had a logical backup that is called as data pump export import, you can say, and we had a recovery manager that creates the physical backup, and also we have tape backups that is also called as physical backup. So in our database we had two types of backup, one is physical backup and one is logical backup. Physical backup is basically done by rman and operating system utility like cp command, and logical backup can be done by data pump or export import old utility, and database backup can be created by rman or is stored as image copy or backup set. So image copy is basically bit to bit on disk duplication of data file, control file, and redo log file. And you can also create image copy of physical file with operating system utilities or rman, and these copies are similar. And backup set is basically created by rman that contains the data from one or more data files, archive redo log files, control file, or sp file. And the smallest unit of backup set is a binary file called a backup piece. So backup sets are the logical thing and backup piece is the physical thing, and these backup you can write to device or as well as you can write to tape drives. So for that you required interface, that is media management library mml, or sbt system backup to tape software, which can create backup to tape. Okay, so these are related informations regarding backups. Okay, clear guys? Now, all done from the database part, okay, system instance part. Uh, Earlier, I said that we had three types of memory. One is SGA, which we discussed. Another one is PGA, which about to discuss. Then the third one is UGA. So these three memory components we have in our database. So PGA is Program Global Area. Can anyone tell me what is PGA? If you have any idea about PGA, as you can see in the diagram, this is the PGA diagram. Yes, guys, dedicated for individual session. Okay, what is PGA memory actually? It is a memory to an specific to an operating system process or thread, okay, because the PGA is a process specific, so it is never allocated in the SGA. And PGA is memory heap that contains session dependent variable required by a dedicated or shared server process, and the server process allocates memory structure that it requires in the PGA. Okay, so the analogy for a PGA is a temporary countertop workspace used by a file clerk. So in this analogy, you can say file clerk is the server process which actually doing the work on behalf of the customer, means client process. And this uh, the clerk clears a section of the countertop, uses the workspace to store details about the customer request and to sort the folders requested by the customer, and then gives up the space when the work is done. Okay, so that is the work of PGA. So if you can see in the PGA, we had stack space area, hash area, bitmap area, and UGA area. And in UGA, we had SQL work area, session memory area, and private SQL area. So this server process has a PGA. Okay, so in this PGA, server process will do the things. Okay, so the program global area is a non-shared memory region that contains data and control information exclusively for use by server and background process. So every server process has own PGA, every background process has own PGA. Oracle database creates server process to handle connection to the database on behalf of client program. In a dedicated server environment, one PGA gets created for each server and background process that is started, and each PGA consists of all these areas like stack space, hash area, bitmap, merge area, and UGA. So PGA is allocated when the associated server or background process using it is terminated. Okay, so whenever these process or server process terminated, PGA is deallocated. So in shared environment, multiple client users share the server process. So UGA is moved into the large pool, leaving the PGA with only stack space, hash area, and bitmap merge area. So please remember that in shared server connection, UGA will not be present in PGA. UGA will move to shared pool or large pool. Clear, guys? Please remember this. You know this or you are listening first time. Okay, first time. So now dedicated server session PGA consists of SQL work area, that is UGA, session memory area, private SQL area, and so first we will go with stack space. So stack space is memory allocated to hold session variables and arrays. Hash area is used to perform hash join of tables. Bitmap merge area is to use to merge data retrieved from scan of multiple bitmap index. Okay. Now in UGA we had SQL area, session memory area, and private SQL area. So SQL work area is basically the sort area is used by function that order data, such as if you are using order by and group by clause in your sorry, query actually. Okay, so on that time uh, this SQL area will be used actually. Okay, so sorting basically done. So suppose you are executing this query, select star from employees, join departments on department ID of both and order by last name. Suppose you are executing this query. I'm typing in your window of chat box. So let's see, this is the query. So what will happen? So here the runtime area tracks the process of the full table scan. Session performs a hash join in the hash area to match rows from the two tables, and the order by sort occurs in the sort area. So if the amount of data to be processed by the operators does not fit into work area, then Oracle database divides the input data into smaller pieces. Then this time temporary table space will come into the picture, and some databases pieces will reside in memory while writing the rest to temporary storage for processing later. So these things, please note it, very important things when execution happens. You got my point, or should I repeat? Repeat. See, as I said, this sort area will be used, okay, or you can say SQL work area will be used where sorting happen. So if sort area is not sufficient for that, holding that result or something, all that data, so what Oracle server process will do, it will writes the data first in sort area, and the remaining data it will transfer to the physical storage in temporary table space for later sorting purpose. So it will divide the data into pieces. Okay, so first piece it will take and sort it, and then second piece it will take from the temporary table space and then put into sort area. Like this it will do the work. Clear? And session memory user session data storage for session variables such as login information and other information required by database session. Okay, and private SQL area, by the name you can see that this is the area which does not share anything. So in that we have a runtime area and persistent area. So runtime area contain query execution state information. So suppose runtime area tracks the number of rows retrieved so far in a full table scan. Oracle database creates the runtime area as the first step of an execute request, like for DML statement. So the runtime is freed when the SQL statement is closed. And persistent area, it will contains bind variable values. So bind variable value is supplied to SQL statement at runtime when the statement is executed. So the persistent area is freeze when only the cursor is closed. So you can see that in my diagram, it is showing the cursor area where it mentioned data area pointer and points to cursor like this. Okay, so I have one figure for that, so that you can understand better. So I am posting here. So see that this is the cursor actually. So this cursor is basically a pointer and it points to private SQL area. You got my point, what I was telling? And then client process is responsible for managing private SQL area. The allocation and deallocation of private SQL area depends largely on the application, and the number of private SQL area that a client process can allocate is limited by one initialization parameter. What is the parameter? Please guys answer me. Only two people is telling Vishwajit and Lakshmi. What else, guys? Open underscore cursor is the parameter which will decide. Okay, so that is and what is cursor actually? So cursor is basically a name or handle to a specific private SQL area. As you can see in the diagram, cursor as a pointer on the client side and as a state on the server side. Because cursor are closely associated with private SQL area, so sometimes they are used interchangeably. Okay, so don't get confused. Okay. Suppose a 20 execution of select star from sales in one session and 10 execution of the same query in different session can share the same plan. Yeah, guys. See, when a server process execute SQL or PL/SQL code, the process uses the private SQL area to store bind variable values, query execution state information, query execution work areas. So do not confuse a private SQL area which is in the PGA with the shared SQL area which store execution plan in the SGA, and multiple private SQL area in the same or different session can point to a single execution plan in the SGA. Okay, so for example, 20 execution of select star from sales in one session and 10 execution of the same query in different session can share the same plot. So the private SQL area for each execution are not shared and may contains different values and data. Clear? Now that's it for private PGA actually. So this picture also I can post you guys to help you to understand better this one. So whenever your connection is dedicated, your session memory will be shifted to shared area, location of shifted to SGA, location of DDL or runtime area will be in PGA. So this diagram, please remember, or this table you can remember. Now come to UGA. So UGA is a user global area, and UGA is a session memory which is temporarily allocated for session variable such as login information and other information required by what can I say database session. So UGA stores the session state actually. So if a session loads a PL/SQL package into a memory, then the UGA contains the package state, which is the set of values stored in all the package variable at a specific time, and the package state changes when a package subprogram changes the variable. So by default, the package variables are unique to and persist for the life of the session. Okay, so the UGA must be available to a database session for the life of the session. So for this reason, UGA cannot be stored in the PGA when a connection is shared, because the PGA is specific to a single process. So that's why UGA is stored in the SGA, and in SGA it will stored in the shared pool. If large pool is there, then it will store into the large pool. And when UGA is when using a dedicated server connection, the UGA is stored in the PGA. Okay, clear? Clear, guys? Okay, so uh, this is all about the database architecture actually. So we discuss Oracle database server. Okay, in the database server, we discuss instance. Okay, and in instance, we discuss SGA, and in SGA, we discuss how many memories, shared pool, database buffer cache, redo log buffer, fixed SGA, right? Java pool, large pool, stream pool, right? And we discuss in-memory area, we discuss mem optimize area, we discuss smart flash cache, we discuss flashback buffer, and we discuss IO pool. So these were the SGA, and in background processes we discuss mandatory background process, we discuss optional background process, we discuss slave processes. So mandatory, how many background process we have, guys? Yes, perfect, 10. So 9. 10, my dear, you forget. And optional, it comes when you enable the parameters, when you require the work to optional, and slave process are the optional process which help the background process. Okay, so that was background, and it was instance related. And now today we discuss about the database. So in database, we discuss about the data file, we discuss about the control file, we discuss about the redo log file, we discuss parameter file, password file, blockchain tracking file, backup files, and ADR files. And in ADR, we discuss background trace file, alert log file, SP trace file, health report, incident package, etc. Okay, and after that we discuss two memory components, which is PGA and the UGA. Okay, so this all was collectively made your database architecture. So I hope I tried to give the database architecture overview with all details and informations. So I hope this will help you in your understanding of Oracle database, those who are new, and also those who has experience, maybe they don't know some points. Am I correct? Which I discuss. because you guys are not responding, so I will cut short the things because you are guys are not responding to my questions. So why I will tell you each and everything. Okay, so that's it for today's session, and next session Geeta will update you. Actually, according to my availability. Okay, so thank you very much for joining these sessions. I'm stopping the recording. If you